Morning all. Thank you for being here this morning so early. This is the network engineering workshop organized by Francis today. Thank you for being here. This is all about harmonizing our efforts for the GREN, the Global Research and Education Network. What we're doing here is talk about engineering, talking about joint efforts on procuring links to support science and educations across the planet. That's a big science project like the Large Hadron Collider. That's big science projects like the Square Kilometer Array, but it's also smaller things, students that work every day across the planets. And today we're going to, this morning in this session, we're going to talk about the next step in bandwidth, 400 gig mainly. We have a nice lineup of speakers. Brenna and Ed will start first with talking about their visions and their ideas about Transpec. Then we have Akashi-san coming up, talking about 400 gig within SciNet, and we'll end with Thomas here session about their plans for 400 gig in Internet 2. So let's start with Ed and Brenna and invite them to the floor here to talk about Transpec.
Welcome, and thanks to Francis for organizing the session. I think throughout the week there'll be a lot of good talks and updates within the network engineering group, so we look forward to learning what everybody's up to. I think that there was a desire coming out of the meeting in Sri Lanka to have progressive discussions around coordinated efforts to evolve the APONET system. You know, we say 400G. And clearly that makes a lot of sense to move the 100G to 400G. But you know, our team is asking questions around whether we need to do that. Is the timing right to go to 400G? Are there the use cases to go to 400G? Are there engineering cases to coordinate these investments in a more sort of focused and science-backed way? So I'm going to talk a little bit about justifications and the things that our team is doing at a high level. And then Brennan will come in and talk about some practical things. No one can hear me? Is that better? Okay, sorry. Do I need to start over? Okay. Okay. So we're from Indiana University in the USA. We have a project called Transpec, which has been around for 25 years, as many of you know. We're a small research team. There's only 4 of us. We currently operate in the Pacific 2 production 100 gig links, one connecting Seattle to Tokyo, and we're part of a consortia that invests in connectivity between Guam and Singapore. So Transpec, we're funded by the National Science Foundation. It's a $4.5 million project over 5 years. We're currently in year 3. Against production connectivity with some services built on top of that. The obligatory map of the links. I showed this slide in Sri Lanka, but I think it gives a good sense of the progress that we're making and some of the justifications we have from moving from 100G to 400G. So Transpec started in 1998 at 35 megs, moved to 100, 155, and then for 10 years, we're at 10 gig. And believe it or not, 2015 to 2025 will be 10 years of 100 gig. And so clearly the technology is becoming ready for us to have, you know, potentially 10 years of 400 gig. So when we look at what we want to do beyond 2025, what we think the community has evolved to in how these links and these systems are being funded, and what we think the role of Transpec 6 can be, I suspect that it will not be simply leasing high capacity links. I think there's momentum in the community, as we all kind of feel within APONET, for doing things together, for joint funding, joint engineering, and opportunities to learn from the APONET engineering groups, our measurement and monitoring efforts, and other studies, to invest very deliberately and collaboratively in the next generation of links across the Pacific, in a way that supports the science needs and the engineering needs. So again, the map of APONET, we've all seen this. This is from May 2022. And I suspect by the end of 2024, we'll need to update this. I think, as you'll hear today and throughout the week, there's a lot of groups moving and looking at 400G. And what I'm kind of proposing is that we need to do this together. There's a lot of value in looking at these investments collaboratively. The way that we designed APONET was we all had funding, we all went and procured links, and then we all got together and said, let's build a system. It's kind of a bottom up. We had the links and then we built the system. But what I think we have an opportunity to do this time around is to think about the architecture and design and the services of that system before we procure it. So we can take data from the engineering groups, from the lessons learned and the challenges that we've identified within APONET, and apply them to building the next generation of the system. And that's kind of what our theme is for this talk and this week, is how do we do that? And who needs to be involved? So Alexander mentioned the GREN. I think if it means anything, the GREN is a sort of scaling up of everything that we do domestically and internationally to look at these collaborative systems together. APONET obviously is the best example, and AER in this community. There's ANA in the Atlantic, NAREX, and others that are all looking to combine resources for mutual benefit. Clearly, some benefits of the system are we save money. We have coordinated service provisioning, collaborative problem resolution, network monitoring, service development, etc. And these things have become very clear. The value is there. But we have identified some things that remain challenges. And I think I've listed, yeah. So some of the things that I think that we can look at and try to change as we go through this process. We all have different missions. For example, the NSF funding is designed to support US science. And one endpoint of each Transpac link has to land in the US. So we can fund US to Asia. We can fund Guam to Singapore. But one end has to land on US territory. That's sort of part of our mission, is US science. And we have I guess, regulations on what we can and can't do. And we all have these sort of varying missions that we have to live up to. But we can incorporate those into the design of the system. If they're transparent and they're clear and they're on the table and they're up for discussion, it shouldn't be a barrier to how we design the system. Distributed ownership of resources. So we go back to, we invest in Seattle to Tokyo and Guam to Singapore, but our mission is to support US science. And so I don't particularly care if we have within the APONET system, if the support for an NSF funded researcher, if their traffic goes across my links, I might own those links, but if the traffic goes via our partners at SciNet or another partner's link, to me, that is meeting my mission. So I may not own the resource, but I'm contributing into the system and therefore meeting the mission. And this is a challenge that, I guess it relates to the varying missions, but it's a hard concept, I think, where we're paying into something and we can't directly relate it to the traffic being on our links and being okay with that. So other challenges, unaligned procurement cycles. Some of us get funding every 5 years, some every 10. Some of us, especially NRENs, have funding, that whenever the engineering and the science support is necessary. There's also engineering challenges that we've identified in the engineering working groups within ANA and APONET. Brenna has been spending multiple years now working in the routing working group, and I guess I'll plug her talk tomorrow, is it, for an update on the routing issues. We do backup paths well, but a lot of times they're reactive. There's a cable cut somewhere, and then we get requests to go and set up backups. we could do this, we could have these backups set up in advance. And we do this to some extent, but I think there's opportunities to improve on that. APANet's a transport network in the end. We don't really do end-to-end performance, but we could. Some of us have resources to do that, others don't. But we could, I think, do a better job of coordinating that. And then, of course, the work that we do here is difficult. Simply collaborating and coordinating internationally is a hard thing to do. It requires resources, it requires commitment, it requires getting up in the middle of the night for meetings. It requires our bosses allowing us to prioritize and do this work. And that's not an easy thing to do. It seems easy. We all do it, but being successful takes real commitment. So I'll transfer over to Brenna, but as we go through this process, we're asking some questions about what Transpac 6 or the next generation of Transpac might look like. I've listed them here, so we want to include as many partners as we can. There's no reason why partnership has to be limited to organizations that have money to contribute. We're looking to align funding cycles and pursue funding models like the Guam-Singapore Consortium and other models that exist in APONET for co-funding links. We want to move from leased circuits to eventually to spectrum. I think it makes a lot of sense from an engineering perspective to pursue longer term investments as opposed to the 5-year and 7-year circuit leases. The work in the engineering groups needs to continue. We need to align our incentives to make our organizations invest in and contribute to these working groups, like the consortia working groups and the routing working group. We can do some really great work there, but it requires commitment, it requires resources, it requires, again, our leaders stepping up and really getting buy-in to make these things work. Other questions, and I'm hoping that these questions can, during the Q&A, maybe spark some discussion. We're looking at use cases. Again, one of our sort of restrictions to funding is we have to make the case for it. We have to identify what the science cases are that are driving demand for 400G. Is it available? It's a big question. When will it be available? When will the market be ready for us to come together and build this thing? Are the NRENs ready? And we're looking at future demand. So can we look out 10 or 15 years and understand what trans-Pacific traffic volume will look like and design a system today that will support traffic in the future? I think I'll hand it over to Brenna, and she can talk about some of the things that we're looking at, some of the developments and some of the ongoing projects we have in the space.
Hi, everyone. My name is Brenna Mead, and I'm the network architect for international networks at Indiana University. I also wear several other hats. As mentioned, I'm the chair of the APAN routing working group. And I also am heavily involved in supporting network research, such as the Supercomputing Conference, the DMC, and Fabric through our interactions with our partners and throughout the world. And so I want to talk a little bit about potential use cases for 400G. We obviously know that we're building these networks for science. So the #1 use case for 400G in the Pacific would be to provide science use cases that need this connectivity. But there's also a number of institutions and partners doing significant network research and showcasing that network research through the Data Mover Challenge, through the Supercomputing Conference, and other network research testbeds such as Fabric, Chameleon, and other network research that happens over the Pacific. We also want to talk a little bit about resiliency, so I will go into that in this. So some of the science use cases that we are looking at in terms of building the case for 400G. High energy physics is obviously the big one. LHC is starting their runs, and we are supporting all of that primarily over the Atlantic, but there are 2 tier 2 sites that are coming up in the Pacific region, and we need to be able to plan out to be able to support those initiatives. There's also nuclear fusion science. There's quite a bit of that happening in Asia, Japan specifically. Astronomy, ALMA, NASA all have are very heavily invested in the in using these research and education networks to transfer data and facilitate their collaborations. Climate, so NOAA, UCAR in the United States. There's also significant research in seismology happening in Asia. And then biomedical science, specifically the National Library of Medicine's collaborations with Japan and other areas in Asia. And then finally, connecting supercomputing centers. So over the Pacific, we facilitate a lot of connectivity between the US supercomputing centers, for example, TAC, NCSA, with partners in Asia. So we want to look at connecting those in the most efficient manner and whether they need to be upgraded to 400G in any timeline within the next 5 to 10 years and what they're looking at in terms of data transfers. Supercomputing. This is an international conference that happens in the United States each year. And last year we had 32 NREs submitted, and almost a third of them were from Pacific region. So from Japan and from other areas in Asia. All experiments that requested 400G last year used the ANA system, so did not take any routes over the Pacific because we did not have the ability to facilitate that connectivity. As the chair of the routing working group, in my head, I think going the opposite way around the world is not the most efficient route, and adds latency, adds distance, adds things that will change the results of their experiments. So it is important to look at how we could support some of these experiments next year and going forward and SC24. We've already, and I believe SciNet will discuss a little bit about their plans for next year, but we've already been informed of an experiment that's planning to do 1 terabit per second over the Pacific region. So over all of APONET next year is the plan for SC24. To do that, we will have to use a minimum of 8 to 12 production links, and we will have to effectively coordinate moving production traffic off of APONET links to facilitate the test traffic that will go over those links during SC. For those of you that have never coordinated an effort like this, it's going to take a lot of time. It's going to take a lot of collaboration, and luckily we do have the APONET system, but if we did have some 400G links, we would be able to facilitate these experiments and coordination efforts a little bit simpler. And also we would have more opportunity and more areas to move the production traffic around the APONET system if we had some 400G links. And again, as these experimenters are starting to really look at single stream 400G, and that's what they're targeting for their network research, they currently cannot do any of that over the Pacific. So they're going to end up using AER, ANA, and going pretty much the other way around the world to facilitate their experiments. And over time, I think these institutions that are participating in these demos in SC25, SC26, the demand for 400G is not going to go away, especially with the data mover challenges that are happening. For example, we just had an example of the data mover challenge. We had a link that was cut, and we had to facilitate a 400G link over Europe, over ANA, that was cut, and we had to actually move it to 100G links, several 100G links, to facilitate the data mover challenge in that time. So the more we think about supporting our network research and making sure that we can facilitate these 400G experiments in the most efficient and most useful way for their research, I think is important for our community. So we want to talk a little bit about US NREN 400G readiness. As a Transpac update, we have a Transpac router in the Seattle PacWave Exchange. We will be removing that router this year. That router only supports 100G, but by removing that router, we will be moving our connectivity to the 400G PacWave Exchange. This will not only this will allow us to support 400G when we are ready and when the community is ready. It also, with my focus on routing, it will shorten the AS path for traffic going over our links so that it will actually create a more efficient path over Transpac. So we're very excited to accomplish that and start getting ready to support 400G over time. PacWave is able to support 400G in LA and Seattle. That was recent as of last year. So they are prepared to support some of those connections as well. And then Internet2 will be discussing today their 400G plans and where they're at. They already have 400G over the Atlantic, and many of their exchange points all of their exchange points support 400G, I believe. Going along with this 400G idea, through NAREX, we are working on facilitating 400G connectivity between all the exchange points in the US. This is a collaboration with PacWave, Internet2, Scenic, Starlight, International Networks, ESNet, Canary, and Ampath. I think this is a really good example of US NRENs and US network operators working together to be able to create faster paths for science through the US. So these links will be available for their 400G and collecting. So you can go all the way around the world except the Pacific on 400G through the US. So as this project continues and the links come up, we'll be using these links to support several of the SC demonstrations that will happen next year, specifically the one I mentioned from Asia, the 1 terabit data transfer exhibition. So this is all to say, are we ready for 400G in the Pacific? If not, what can we do to answer that question? So something I'm actually very excited about is myself and my team at Indiana University will be doing a traffic projection study over the Pacific. Because of NetSage and the work that we did with NetSage to add all the APONET links to NetSage, we have flow data from all partners, well, most of the partners in the APONET system. So we will be using that flow collection data to do forecasting models for predictions of network traffic across these links for the next 5, 10, 1, 5, and 10 years. The links that we will be specifically looking at are Transpac 100G Seattle to Tokyo, the Guam to Singapore link, and then we will also be looking at traffic projections across the entire APONET system. The objective of this is to facilitate proactive network capacity planning for all of us in the Trans-Pacific region to help make decisions about future capacity and share those results with the community. We hope to present these results at Internet2 Technology Exchange towards the end of this year. And we want to be, and if anyone is interested in collaborating with us on this project or has ideas for how to facilitate this and make sure that the community is involved as we look at this study, feel free to come reach out. I'd love to talk to you more about your thoughts and how we can help the community with this type of work. Going along with that, we also are, I mentioned NetSage. We are working on the next, essentially the next iteration of NetSage, which is a collaboration between ESNet, ourselves, Internet2, and a variety of other partners that are looking for measuring and monitoring tools for their system. This will be called Metronova. Apologies. It's based on the perf sonar model. I don't know if many of you know the perf sonar model, but that's just another collaboration to develop a product that the community can use to troubleshoot, monitor, test, things like that. So we are going to develop and share our architectures, technical components, patterns, best practices, and policies to the entire community. I think it's really important to note that both of these projects, that both the traffic projection project and the Metronova project, are going to be available to the community. The results of these projects are not going to be insular. We are going to share them, both what we learned and lessons learned and our successes, and all of that will be shared with the community. The goal is to educate the RNA community and enable effective use of these measurement tools. If you want to learn a little bit more about NetSage, I will be discussing it at the routing working group meeting tomorrow, and showing a little bit of how to use the tool. And you can get a good idea of where we are now and kind of where we want to head with Metronova as a US collaborative measurement tool. And then we also want to make sure that we're providing growth opportunities for students and staff that work around these collaborative entities. And to close, I would say we are open to any of your questions, any discussion you want to have about 400G in the Pacific. We are also looking at, we really want to determine if this is a need for our community. And if it's not now, when is it? What is the timeline for this need so that we can all plan effectively as a community and make sure that this APONET system that has proven itself to be incredibly successful and incredibly collaborative, and we use it all the time to solve problems, make sure that we're making decisions together within the APONET system going forward, and thinking about those timelines. So thank you. if you have any questions, please feel free to raise your hand. These are our emails if you need us, and we'll also be around all week.
Yes. A follow question in the back. Francis. Please stand here. Yeah.
I'm talking to a vendor and they say that on the Pacific side, the cable systems are not quite ready for the 400G. Because a lot of the cable systems were for the old cable system. I'm just wondering how ready are cable systems to take on the 400G and over to the floor, not just brand, but maybe start with brand.
Christian, do you want to take this one, or I can try?
Sure. So we said
all things, it depends. And so there are active upgrade projects right now on existing cables that are moving to 400G in the Pacific. There's new systems that are 400G capable. It seems like there is also an element of business drivers that will determine whether or not 400G is implemented initially. The technical side of it seems to be that in general, it's going to depend, of course, but in general, 400G is achievable in the Pacific. I don't know, Brennan.
So yeah, we were at PTC last week and had a lot of conversations there. A year ago, we were told within a year, and this year we're told within a year. So as it goes, right? As it goes. But I think we have reason to believe that by the end of this year, there's some commercial viability. At least that's what we've been told. We'll see. We'll continue to monitor, and you know, at APAN58, we'll be happy to provide further updates.
Yeah, and I would also add, just based on some of the conversations that we've had throughout the community, a lot of people are targeting 2025, especially with all the new cables that are coming up. A few of the cables that exist are actually ready for, bonded 200G. Where so to the client, it looks like 400G, but it's not a single stream 400G, but there are several cables that are ready for that, which could be an interesting thing for our community to look at in terms of testing or looking at feasibility of 400G over Trans-Pacific. So there are cables that are available for that, but yeah, we're really targeting the newer cables and targeting vendors that are, rotating their equipment to facilitate being able to run 400G over old cables. And we have to be really specific about whether that's single stream, dual stream, or 4 stream.
Yeah.
So.
And I think, we'll see in the next presentation that some of Akashi-san will show us that there's, 4x100 is already happening. We're already moving on that.
Yeah. If I have some voice to say, so from my point of view, yes, for sure, why not? Yeah, that is the current status for the Pacific Ocean. So the Alison over there is trying to build one of these. So we are quite sure that we can provide 400G in a coming, let's say within a year or something.
Yeah.
One more question, Francis.
Over the I get it that the Europeans and the US have come together and made a 400G to spectrum procurement. Maybe that would be share how you go about doing that and how that thing comes along. Yeah.
Christian, you?
Sure.
Yeah.
So we had started on a managed spectrum agreement back in 22 on for a new system. That I think was fairly early days for the concept of spectrum in the commercial marketplace. And so there's a lot of, let's say, education that had to happen. I think now the market, the providers in the market have caught up with the idea that spectrum is a viable product that people want. But even now, there are some cables that are new. You can talk about spectrum, but they get a little nervous, I guess. It's a little resistant. It's still there. So I think it's over time, it'll be more and more acceptable. But it takes, frankly, a lot of effort, a lot of engagement with the provider, a lot of conversation to not only get them to understand why it's important as a product, but that it's something that is not going to in some way harm their business model. So there's, like I said, it's a lot of education, a lot of persistence. At least that's how it was for us.
Yeah, I would add that I think we as a research and education community, I think we have to make sure that we're always pushing those business entities. I know it's hard for a commercial entity to really push that business case for 400G because they don't necessarily have the customers for it yet. But I think we as a research education community, and we in our history have really been drivers of some of these innovations in the past. And I think we need to keep that mindset as we go forward. Is, when we started a lot of internet connectivity research and education in our history, there wasn't a business case for it yet. But then, build it and they will come, and they did. And so I think it's really important as research and education network operators and people who are thinking about this in the next 5-10 years, just remember that we are here to innovate and we are here to support science, and we are here to make sure that we continue that mission. And and part of that is convincing some of these commercial entities that this is a useful business case, and that it will, that there's a reason to do it. So,
thanks, Brenna. Yeah, I think for me, I can be really proud of what we are doing here together, how we collaborate. Ed showed this slide with all the challenges there, and when we handle those challenges in the right way, I'm sure that science will win all over the planet. Looking forward to your projection for the bandwidth planning. Also, somebody's here in the room, please go have a chat with Brenna on that. And one thing I wrote down was what Ed said. We're all in the same boat, right? So talk with your funders and the government that when you're contributing to the global system, you're contributing to your mission as well. So it's not only a national thing; it goes well beyond that. Having that said, we're moving on to the situation in the Japan. Akashi-san will talk about 400 gig deployment in Japan.
Oh, thank you for introduction. I'm Osamu Akashi of NII SciNet. I'm very glad to have a conversation with face-to-face. So because my previous several presentation was via Zoom, so I'm very glad to have the direct discussion with participants. So today's my presentation's topic consists of 3 topics. One is plan of 400 gig international line. And the second topic is the next generation of GXP in Tokyo. And the final report is a 1.2 terabps transmission experiment. Okay, this is a brief introduction of SciNet. SciNet is a Japanese ultra-high-speed networks that connect to the almost all major Japanese university and large experimental facilities such as BEL2, J-Park, LSC, and ETAS, and so on. SciNet also connects supercomputers in Japan and also connects the storage facilities in Japan. So currently, we have connected more than 1,000 organizations in Japan. So currently SciNet is a sixth generation and started in 2022. So SciNet 6 future is here. One topic is nationwide 400 gig lines. So SciNet connect all Japanese 47 prefectures using the 400 gig technologies. Little exception is Okinawa Island, denoted this yellow lines due to the restriction of the technical problem. So it connects using the 100 gig line. Almost other part are using the 400 gig lines. Another capability is 5G mobile and private 5G. It is access lines. And third point is secure and flexible services by NFV and routers. And the final one is near 200 gig BPS or more international lines. This is first topic. Okay, this is previous SciNet 5 topology before SciNet 6 until 2022. We constructed the worldwide 100 gig rings. So in this sphere, Tokyo to Los Angeles, New York, New York to Amsterdam. Another line is Tokyo to Amsterdam directly. It using the 100 gig technologies. And as a connection of the Asia, we implemented the Tokyo to Singapore line. And this is connected through the SOE. And as far as the United States, we connected the Pacific Wave and MANLAN, and in the Europe, we connected at the Netherlands. So this is a SciNet 6 change. So from the 2022, as denoted in the right circle, we increase the bandwidth to Tokyo to Los Angeles, from Los Angeles to New York. This is upgraded from the 100 gig line to 100 gig lines. And we also add the new lines between Tokyo and Guam. So this is connected as the GoRex. So as you know, the previous topology, we use the Trans-Siberian lines. This is the shortest path from Japan to Europe, but as you know, a lot of problem here. So we procure the new lines for new JP EU lines. So this is a North Pole view of the new lines. So previous lines, RTT is 150, but unfortunately, next new line is RTT is increasing from 150 to 220. But we will increase the bandwidth from 100 gig line to 100 gig lines. So we are finished the procurement and doing preparation of the next line. So this is a new map of the new EU JP lines. We will also connect at the Netherlands. So we are at the same time, we will replace the routers at the Netherlands. So sorry for the inconvenience of the replacement, but thank you for support to new connection and new 400 gig connection to IX. Okay. So the target date of the replacement is next March, in the middle of March. So we are now preparing the replacement. So this is the change from the AER point of view. So this current map is Japan to Amsterdam. So logically, it is not changed, but actually, this bandwidth increased from the 100 to 400. And physically, not Trans-Siberian line, but this line traversing on the United States. Okay, this is maybe most important update. We are now preparing the 400 gig line procurement. So we would like to exchange the new exchange the new JP United States lines. So, okay. This red line shows the 400 gig lines, and we are now doing the procurement between Tokyo and Los Angeles to New York to Amsterdam. We are now considering the 400 gig lines to replace, and also it's connect to the Pacific Wave and Manlan and Netherlight with the 400 gig interface. So thank you for support for upgrading the this connection. This target date is 2025 for in maybe April to replace our 100 gig 100 or 200 gig lines to next new 400 gig lines. Okay. This is a small update about the collaborations. We are now acting with the cooperation with the ANA, APONET, AER, and last year, last APAN, we are also signing the MOU with the East Asia Resilient Backbone Network collaborations. This is the update of the collaborations. Okay, and second topic is a new GXP at Tokyo. Currently, we are preparing the 400 gig capable switches or routers in the Tokyo. And the target date is we are now considering the operation on from 2025 second quarter or third quarters. And we will prepare the two switch or routers in Tokyo, and this and set in the major data center in Tokyo. So these two physical switch or routers are connected by using several 400 gig lines. And the name of the new GXP is under discussion. Okay, so this is procured and operated by Cynet, but supported by Shinji. Shinji is the abbreviation of the Coalition for Interoperable Network of Japan and International. But namely, it is an alliance of the Japanese lanes, such as Muffin, NICT-JGN, NI Cynet, and Wide Arena Pack. So this GXP was supported by these members. Sorry for not preparing the detailed architecture because it is under procurement. So this is the image of the GXPs. So as I mentioned, 400 gig capable routers and two routers are connected using the 400 gig lines. And currently we have a current GXP Tokyo. So we have now plan to connect this new generation of GXP and current GXP by using the 100 or more lines. So we hope the Shinji members are connecting to this new generation of GXP and possibly other lanes such as Transpac or other members to connect this new GXP. This is a future plan. So final topic is 1.2 terabps for optical signal transmission and data transmission of 1 terabps. So this is published in the this URL. So last year, Japanese consortium such as consist of the NII, NTT, NTT West, and Fujitsu established such record. They constructed 1.2 terabps per optical wavelength and successfully achieved the throughput transmissions. And the second experiment using the MMCFTP, they achieved the data transfer over 1 terabps using a pair of general purpose one socket servers. In this experiment, NTTs provide commercial optical fiber, NTT digital signal processing technology and device, and Fujitsu next generation optical transmission systems. And finally, NII provides MMCFTP, massively multi-connection file transfer protocol. In the field trial 1, we constructed the network in this topology, Chiyodaku in Tokyo, and use the Yokohama a little far from Tokyo. And distance of this network is this line is 33.6 kilometers. And both ends we use the turnaround technology, and totally we repeated the turnaround 5th time. So total is over 336 line are used. So in this environment, at the tester level, we achieved the 1.2 terabps of transmission over this in this environment. And another experiment is conducted by using the servers. As you know, the yellow circles, general purpose server are connected. One is for sending server, and another one is the receiving servers. And you directly sending the data. And this experiment, we achieved the 47 terabyte transmission, and at the rate of the 1.0 terabps transmission using the real data transmission. So in this experiment, Primo Sensei sitting here conducted this experiment. So detailed technical problems, he will answer questions. Okay, it's all. Any question?
When you give the control for 4 times 100 gig, are you going to use the same fiber systems for residency?
Yeah.
Or
Sorry,
just price?
I missed the explain about the control. So we are now preparing the 4 same route fibers, and we will use ECMP to control these 4 lines. Because another possible option is lag, but the lag is in this case we have to use a long distance line, and this is the first time in the world. So vendor don't recommend to use lag. So we will use ECMP, but the ECMP has also another problem. If one line failed traffic, how do we distribute the another lines? So ideally, we expect the uniform distribution, namely 1/3, 1/3, 1/3. But practically under the verification, failed traffic diverted to the 1 lines currently. So we are now investigation to how to control the 4 lines. Maybe ECMP has also problems. Yeah.
Okay, but in that case, all 4 lines are depending on the same cable system, which may be variable for the single fiber cut.
Yes.
So do you have any idea?
We consider the different route, but the different RTT is something difficult to control at the normal level. So we procure the same route lines. RTT is the same. This is a condition of procure.
Yeah, I fully understand the difficulty.
Yeah.
I'd like to know your intention. Thank you very much.
Thank you.
It's also this is part of the AER system, right? So there's also backup across the other lines in that collaboration. It's really exciting news that we have the first 400 gig link in the AER system. I'm quite sure that others will follow.
Thank you for support.
So really impressing what you're doing on 1.2 terabit. I was already excited that our team will even install 800 gig, but this goes above and beyond. More questions for Akashi-san? No? Okay. Thank you.
Thank you.
Then we move on to Thomas, and he will tell us more about the 400 gig plans in Internet 2.
Hi, good morning, everybody. My name is Thomas Arnetta. I'm from Internet 2. I'm the International Engineering Program Manager. I'm joined by my colleagues, James Deedon, Vice President of Network Services and Research Engagement, and Christian Todorov, Senior Director of Business Development. Today, we're just going to go over some brief updates of what's been going on with Internet 2 for the last year, and some of our initiatives such as Insight Console, Routing Integrity, NA-REX, which Brenna and Ed talked about from the IU presentation, our exchange point upgrades, what we're doing in the Atlantic for 400 gig, and then what we're doing as well in the Pacific to support 400 gig development. So since the last APAN, which frankly, I don't know the last time we were here, but we have James, who's our new Vice President for Network Services and Research Engagement. James comes from a GPN, the Great Plains Network. He was the Executive Director there for several years. And when he came over to Internet 2, he also had research engagement brought under his purview. In addition, we've also done better program support for BGP skill development between NRENs and for the community for just more cohesiveness there. And we are also in the process starting to bring up our new packet hardware. So, we brought up 400 gig several years ago, and now we're in that refresh period. So we're starting to test that in our lab back in the US. In addition to that, we are about to roll out the 3rd generation of Open Science Data Federation nodes. There's going to be 10 in service on our backbone today. And in addition to that, our teams are continuing to grow, engineering, software development, and programmatic support. I'm, part of the international team that's been, grown out of this. Of course, we get to have our map here of our international presence. As you see in the small green here in the Pacific, that is the 100 gig from Guam to Singapore, which we are working with ARNet, RENAPAC, and Indiana on. In addition, we have our 100 gig from Washington, D.C. to London with Canary, and then our soon-to-be 400 gig from Boston to Bruges, France. Oh, and just really quick, those white lines are NA-REX. I'll talk about that shortly here. But this last year, we also were able to roll out Insight Console, which is a looking glass in March. And then in October, we rolled out Virtual Networks, which just gives more power back to the community to build their own networks. And it comes with a API underlying it to kind of bring in, for end users to query Insight Console for data, and as well, kind of set the stage for new integrations such as AutoGoal and Sense. As in terms of our routing integrity, as yesterday, we were part of the BGP Watch presentation workshop. You see that there's a lot of issues going on the internet with route hijacking. So Steve Wallace and Jeff Bartik, Internet 2, have led this effort to standardize RPK and ROAs in the RNE routing table there. This is taking some time, but it's making progress. And with that as well, though, they've also started the ASPA working group as well. More work is to be done here. There's some legacy things going on with Aaron, but the community is moving forward with this as well. As for NA-REX, as IU mentioned, that this is a consortium of operators, connectivity providers, and science networks in the United States, in North America. And really, what has come out of it is that we're coordinating with one another to establish operating principles, common tool sets, and provisioning mechanisms. And this is being used to support data links for experimental traffic and network research. It was originally formally adopted at Supercomputer in Denver. We saw about 20 NREs use it for the exhibition. And the first links that were brought online were from Chicago to Seattle, and then Chicago to LA. Chicago to LA is a shared link. For 2024, we are planning to deploy a NetSage type of style dashboard, and then also bring additional 400 gig links online. As for our global exchange points in Boston, New York, and Washington, D.C., they are now online using the new Aristas. And they are currently being in the process of being integrated into our backbone network and also NSO and Insight Console. And they're also being used for the Amity provisioning, the 400 gig Atlantic provisioning for ESNet. And speaking of our 400 gig in the Atlantic, they are planning to be fully deployed by February 7. There's going to be one between Boston to Bruges, France, with Internet 2 and Canary, and then two for ESNet from Boston, France, and Boston to London. As for the Pacific, we are continuing to provide support and for diversity and diversity in the Pacific region, and we're taking the vendor relationships that we have in the Atlantic and try to use that in the Pacific. Thank you very much. Is there any questions?
You mentioned RPKI.
Yes.
I think that's also really important that we do that as a community here together, because you rely on the information that you get from partners around the world. I think. Pushing to the room. How far are you with implementing RPKI? Nobody?
No. I did. Oh, so we have implemented the RPKI for us. Maybe. I mean, the typical RNet also that is basically it's and we are running on the Juniper router with RPKI, and it's been active since for almost 6 years for now. So it's been running quite stable. So from this region, so that we have the quite good I don't know, Kato-san may have no more detail, but the allocation of the IP address was quite in a steady process. So actually I don't see any kind of the problem was the issue in the role in a sense. So in this region, so we are quite straightforward process for that.
More questions for Thomas? For other speakers? We going to conclude this. These speakers here today did a great talk, but they are also driving the international impact among the research and education networks and in the G-Brand. So a big applause for that. Thanks. So we have a little bit more time for coffee, I think. Thank you for coming, and we'll reconvene in this room at 11, am I right, Francis? I think so. Yeah. Okay, thanks.
Hi, please come on in and grab a seat. Otherwise, you won't have a seat quickly. Okay, welcome back, everyone. I think the morning session has been very good. The first session about 400 gig connectivity, and you see that 400 gig is slowly coming to be a reality, and we have to start preparing for it. This session is going to focus on POPs. There are a number of points of presence in the region that are critical for the operation of the network. Hong Kong Open Exchange, run by JUCC HARNet. We're going to have something from them. We're going to hear something from about Singapore Open Exchange. We're going to hear something about KDI, who is operating the Japan Exchange Point. You see, so you got Singapore down south, you got Hong Kong in the middle, Japan Open Exchange, and then we have the Pacific Wave. Christopher is with us, and he's going to share with us what's happening over the side. Okay, so I see that these are 4 critical points, and I'm sure there are a few other points, pop of presence, which I've not covered, and that's just too many of them to cover. Let me start out with HARNet, Hong Kong Open Exchange, and I think Wyman is speaking, right? Yeah, Wyman will be sharing that with us about the Hong Kong Open Exchange.
Thank you, Francis, for the warm welcome. And today, our JUCC hasn't been going to APAN for a couple of years because of the city lockdown due to COVID. And we are very glad that we have an opportunity to go here this year and share a few updates of the Harlet and the Open Exchange with us. And first of all, I would like to introduce a bit, just one slide about JUCC. Perhaps not everyone had heard about JUCC. And actually, JUCC has a very long history. It was incorporated in September 1970, more than 50 years ago. It started with two members, the Chinese University of Hong Kong and the University of Hong Kong. And then the Hong Kong government, like everywhere in the world, expanded higher education. And now there are 8 public universities in Hong Kong funded by the government. And so JUCC has expanded from 2 members to 8 members, and also 11 affiliate members, which include some private university, as well as some vocational training institutes. And so JUCC is a consortium formed by the 8 government-funded universities. And our mission is to foster collaboration among institutions. And in 1985, JUCC established the first research and education network in Hong Kong, which is called Hong Kong Academic and Research Network, the Harlet, in 1985. And later, in 2016, because there are more overseas collaboration, so we set up another research and education node in Mega I, and we call it Hong Kong Open Exchange. And that Open Exchange was hosted in Mega I, the biggest data center in Hong Kong. And the purpose of setting up a Hong Kong Open Exchange is to share more resources, computing resources, network resources with other NRAM partners in the world, because there are a lot of research collaboration between Hong Kong and other regions. And I think, like Singapore, universities in Hong Kong has very active and research with very high impact. I mean, both regions in Singapore and Hong Kong. And for the Open Exchange, we have the equipment hosted in Mega I, and our equipment is Juniper MX 10,003. We support 1 gig, 10 gig, and 100 gig ports. And we set up persona, and we connect different R&D network in Mega I. And this is the Harlet, which was established in 1985. And it is actually a fully resilient wide area network that links up the 8 universities in Hong Kong. And as you can see, everything's resilient. Every institution, universities that brought the routers to connect to 2 data centers, which are hosted in the Chinese University as well as the University of Hong Kong. And we have almost a Mueller equipment set up in both data centers. And the Harlet is serving 100,000 students and also many researchers in Hong Kong. And we have about more than 20 gig international traffic. And we connect to the Hong Kong Internet Exchange for local internet traffic, which is more than 25 gig each. And this is the Hong Kong Open Exchange. We connect the Open Exchange with Harlet by two 100G links connect to the CUHK data center and the Hong Kong U data center. And the Hong Kong Open Exchange also pair with some RNE network, which include NICT, SingleRAN, CERNet, CSTNet, QNet, as well as other commercial cloud provider like Google, AWS, and Apple. And this is the equipment that we have in Mega-I. And Mega-I had our RNE network had already reached about 40 gig traffic. And it is anticipated that after the COVID, we will have more and more active research with overseas partners. So we anticipate there are enormous growth in internet capacity in the coming few years. Since we haven't present Harlet update in the previous 3 or 4 APAN meetings, so I think this is a good opportunity for us to make a few updates, and most of the updates may be heard from other NRAN's presentation in previous meeting. But it is well for trying to repeat it because we focus on Harlet update. And in 2022, we have upgraded the border router of the full members, totally 16 border routers, like this diagram. And the red circle means a border router. We upgrade it from Cisco product to Juniper. And we have a very strict tendering procedure. So we cannot pick whatever brand we like. And we conduct a POC, several days POC, together with different vendor like Cisco, Juniper, Huawei, X3C, and so on. And finally, we found that Juniper's MX204 product is very cost effective. So we upgrade the 16 Cisco router to 16 MX204 router. And the second update is we didn't have the full resilience connection to Hong Kong Internet Exchange, the commodity internet in Hong Kong. And in 2023, we have set up a MX204 Juniper router in University of Hong Kong data center and connect to another Hong Kong Internet Exchange site through a 100 gig link, which is in the green circle. And the third update is for the Hong Kong Open Exchange, we also established 2 100 gig link, which is the brown circle from the Harlet, the Chinese U, the Hong Kong U data center to Mega-I, the Hong Kong OX data center. And during the past few years, we also joined a number of big research network. The first one is APANET. Thanks for Francis SingleRAN. They invited us through the steering committee of APANET and AER. And we had actually co-share with SingleRAN, NICT, NSCC, Singapore, Hong Kong, Japan 100 gig circuit. And an MOU was signed in 2021. And then we joined the AER, we joined the APANET in 2021, 2022. And we also had a MOU signed with CERNet in 2021. And more than that, we also actively participate in other research project, like Professor Ann had the BGP Watch project, which we collaborate with Tsinghua and other NRAN, including SingleRAN and APAN57, and other Southeast Asia network. And I think Professor Ann had conduct 4 sessions of BGP Watch yesterday. Yeah, it is a very interesting platform. Yeah. And last year in August, APAN56, we have another MOU signed to establish the East Asia Resilient Backbone, which is a collaboration between 6 NRAN, the CSTNet, JUCC, Christie, NICT, MII, and SingleRAN. And we set up a layer 2 backup link between the East Asia network backbone. So this is a summary. The Hong Kong OX had peer with Asia Connect, NICT, SingleRAN, and so on. And we welcome participants to peer with us. And for the future plans, we are considering doing more for Asia Connect, as well as we are considering setting up a research platform, such as Science DMC, yeah, in Hong Kong OX. And if any NRANs are interested to peer with Hong Kong OX, they are very welcome. We have the layer 3 connection and also layer 2 connection, like the East Asia Resilient Backbone, which we can set up layer 2 connection with different NRANs. And as I said, we have hundreds of active research from Hong Kong researchers using HARLAC. And I call a few examples. The first one, the research range from biological science to high energy physics to machine learning, big data, and genetic engineering. I've picked a few examples. Now, the first one is the research in the biological science school in University of Hong Kong. And they have conducted a lot of research on environmental science and ecological science. And this is the research they have. But I'm not in that field, so I'm not too familiar with it. Maybe you can check with your researchers, see whether they would like to partner with the University of Hong Kong. And the other research project is between HKUST and MIT. They have a research alliance consortium. I think it has been signed more than 10 years ago and still running actively. And their research include Internet of Things, data science, robotic science, and biometric science. Yeah. And we have HKUST colleagues here. If NRANs would like to know more about this, I think Samuel will definitely provide more information for it. And also in the University of Hong Kong, we have data mining in genetic data set, which is a very current active research field. And in CUHK, they have some high energy physics research with CERN, and they set up some high performance computing cluster in CUHK and connecting to CERN. And also different area like astronomy. Hong Kong U has some research major telescopes and making use of very low energy sensitivity telescope technology with machine learning. And I think those are the research projects that Hong Kong is currently conducting. And if we want to learn more about the HARLET and Hong Kong Open Exchange, you are welcome to go into that website, www.harlet.hk. And if you want to join HKOX, you are welcome to leave us a message, and we will reply you. Yeah. Thank you very much. This ends my presentation. Thank you.
Any questions? I do have one question.
Yeah.
I see that there's connectivity to CERNET.
Yeah.
What's the policy on those connectivity, and what's the bandwidth down there? Yeah.
Actually, we have two connectivity. One is 155 megabit per second.
Okay.
Yeah. Because you know, bandwidth going directly to China is very expensive. And the other one is CERNET 2, which is a 100 gig connection, but that only support IPv6. And we actually will have a meeting with CERNET Jennifer on Thursday, and hopefully we can see whether we can improve the peering or the route announcement. Yeah.
Because I recently found out that LHC1 tier 1 China is has become a tier 1 for LHC. So there might be a lot of traffic going up and down. So I'm just wondering, it's coming through Hong Kong. So how are we trying to support that? Do you know anything about that?
Sorry, I don't have too much idea. Yeah, maybe.
Yeah. Maybe you introduce yourself.
Oh, yes.
Yeah. How do I know it?
Joe Hui from Tsinghua University, and also the service manager for the 10 knock. Actually, I just some comments from 10 backbone, because maybe you know, for the 10 backbone, we have activated LC1 period together with also NICT and the joint and I think that Transpax. So I think maybe there is another way for us try to just enable the interconnection between like the CCNet and the CERNET to our international partners through the 10 backbone. But now, you know, as I know, CERNET has not activated the LHC1, but because it's so far we have not get the requirement from our customer, you know, due to the some special policy for the campus network in China University. So that's just information based on the 10 backbone. Thank you.
Thank you very much on that. Any other questions from the floor? If not, thank you very much for sharing with about Hong Kong OX. Okay, thank you,
Francis.
Okay.